Okay, this is the practice test for chapters 1 and 2, and it says here that graphs and tables are examples of descriptive statistics is what we're looking for here. A mean of a sample is an example of a statistic, whereas a mean of a population is an example of a parameter. Same is true if you're dealing with any statistic. It could have said a percentage of a certain amount of responses from a sample is a statistic, whereas a percentage from a certain amount of responses from an entire population is an example of a parameter. So the idea here is anything that comes from your sample is a statistic, anything that comes from your population is a parameter. Why is the symbol for, or what is the symbol for population mean? Well, that's mu. It looks like a U. What is the symbol for sample mean? X bar. What is the symbol for population proportion? P. What is the symbol for sample proportion? P hat. What is the symbol for population standard deviation? That's sigma. What's the symbol for sample standard deviation? That's S. Which can rarely be calculated? A parameter, because you'd have to sample the entire population to calculate a parameter, and that's rarely done. How dispersed the data is can be measured by the standard deviation. A survey of 100 American dentists was taken to see if they recommend Plaque's mouthwash. 90 of the 100 said yes. What was the population? What was the sample? Give the statistic and label it. And what would be the parameter? How would you label it if you could calculate it? Well, for this problem number 6 here, the population is American dentists. The sample is 100. The statistic is P hat is 90. I believe it was 90 out of 100, right? P hat equals 90 out of 100, or 90%, and the population parameter would be the percentage of American dentists that recommend Plaque's mouthwash. We don't know what that is, but if we were able to calculate it, we would label it with a P. Okay? This data here says from the following data, calculate the range, and then we want to, from onward here, it says put the data into 4 classes and so on. So we would just type this data right here into the Excel sheet on raw data, which I have typed in, and it says to put it into 4 classes, and there are no decimal points to the right, so make that a 0. The range is calculated right here for you, 43, and here's the data broke up into the 4 classes. The first class would go 50 to 60, second class 60 to 71, and the frequency and so on. Okay. Number 9 says to make a stem and leaf diagram for this data in problem 7. So you would make the stem the tens position, so you would list 5, 6, 7, 8, 9 for the stem, and the leaf would be the ones unit. So you would have 0, and then in the 60s, after the 6, you would have the 2 and the 5 and so on, and that would be the stem and leaf diagram. And the answers are at the end of this also. Okay, so for problem 10 it says for the data below, what is the upper boundary of the first class, lower boundary of the third class, and what is the class width? Okay, the upper boundary of the first class is halfway between the upper class limit of the first class and the lower class limit of the second class. So in other words, it is 9.5. And the lower boundary of the third class would be half the distance between 15 and 16, or in other words, 15.5. And the class width, just take any lower class limit and subtract off another lower class limit, and we get 6. So the class width is 6. But we could also do this in on the Excel sheet on the group data area, putting in our limits here of 4 to 9, and then I think it went 10 to I think 15, and then 16 to 21. I believe that was the way the classes work. Delete your extra data here, and let me make sure I put in the correct frequencies here from the problem. And they were 3, 2, 1. And on the right hand side, this tells you the lower class boundary of the third class is 15.5, the upper class boundary of the first class is 9.5, and the class width here is 6. This one says for the following sample, find the mean, median, mode, range, variance, and standard deviation. Well, we would put this data 1, 2, 3, 10, 9, and so on into the Excel sheet under raw data, we would put those values in right here, and your mean, median, range, and so on would all be calculated right here. For the standard deviation, since this said this was sample data, we would use sample standard deviation, the number right here. Now I didn't put those values in, but you would just put those values in and you would get the answer to that problem. The next problem says, for the population, find the standard deviation. Well, we would just put 1378 in, and it would tell us our population standard deviation right in that cell. Okay, this gives you grouped data, 50 to 59 and so on, and it gives you the frequency, and it says to make an ogive. So we would just put this data into the Excel sheet under group data, and we would put in our values like 50 to 59 and the frequency, and just keep that rolling there, and we would get our ogive down below. For 15, it says, for the following sample data, calculate the mean, median, mode, and standard deviation. Well, I believe may have already done this problem. If not, you just put this data right into the raw data section, and everything is calculated for you automatically. Since it says sample data, make sure you use sample standard deviation. And problem 16 says, for the data in the previous problem, make a table that has 4 classes and calculate the mean for the group data, median for the group data, and third quartile. So in other words, after we get our data in the raw data area, we would say that we want 4 classes. We'd have to put the number of decimal point places in here as being 2, and then we would copy it over by clicking this button, and it would copy it over to the group data sheet where we would get all of our answers to for that. On the group data where it says third quartile and so on, remember that what you need to do is in the group data sheet, when you're there, when it says quartile, remember you have to put that in right here, that the third quartile is equal to the 75th percentile, so you would put 0.75 in there, and you would get the right answer once you put in your correct data into the raw data and copied it over. Median, again, is equal to the 50th percentile, so you would just type in 0.5, and again, your answer would be right once you put in the correct data and do the problem. So let's see, 17 is a person wanted to test the claim that the average amount of soda a male college student drinks in a week is 72 ounces, so the researcher sent emails out to 1,000 male college students from across the country and asked, how much soda do you drink in a week? The researcher got responses back from 800 male college students and found the average to be 100 ounces. What was the population? Well, I believe it was male college students was the population. The sample was not 1,000 males. It's the people that did reply back to your questionnaire. So your sample was actually 800 male college students. What was the statistic? It would be that the X bar, the average, was 100. X bar equals 100. And the parameter is the average amount of soda that a male college student drinks in a week. And we do not know what that value is, but if we knew it, we would label it mu. And then finally, 18 says to make a stem and leaf diagram for problem number 15. And for problem number 15, where we had those decimals, I would let my stem be the ones and tenths unit and the leaf be the hundredths unit. You could also do this problem, since it goes up to 2, you could let the ones unit, the stem be just the ones unit, and the leaf be the tenths and hundredths unit. But I would say the best would be the first option, where the stem is the 1 and tenths unit. And that may be every question off the practice test. And then the answers again are at the end of the practice test. And that will do it.